So, a very good morning, all of you. Welcome to the class. This is the third class for uh, preparation for JEE and NEET 2020, right? The revision classes. So, let us start with the class for the day. Before we do, a basic plan of how we'll be going about this class, telling you all in a minute. Yes. Please let me know first. All those who are able to clearly hear my voice, raise your hands. Those who are able to clearly hear my voice, please raise your hands. Yes. All right. So I can see that all hands are raised. That means students are able to clearly hear my voice. All right, bachalo. Then let's begin with the class. So thank you. You can bring your hands down. Before we start again the class, let us have a short prayer and short meditation, right? All of you, please join your hands. Close your eyes. It's said that faith can move mountains. If you have belief, everything in the universe will make sure your belief will make a difference, right? So, everyone, close your eyes. Smile on your face. Before I start with anything, like always, I'll remember my gurus who have taught me all of this knowledge so that I am being able to disseminate in this to all of you, right? Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Let there be a smile on the face. One by one, all of us will be taking 3 deep breaths. On my count. Count 1. Breathe in. Slowly, with a smile on the face, breathe out. Once more. Breathe in. With a smile on the face, breathe out. Once again. Take a deep breath in. Allow your mind and your body to be free. With a smile on the face, breathe out. We'll pray. Dear God, you might repeat this, everyone, at your places, right? Dear God, we thank you for this life and all its miracles. We thank you for such good health, wealth, and wisdom. We thank you for placing into our hearts big dreams. We thank you for all the guidance, motivation, and mentorship received to make those dreams come true. Dear God, I know your favor is upon me, my family, health, wealth, career, and my finances. Dear God, I thank you in advance that I'm clearing JEE 2020 and NEET 2020 in flying colors and becoming a great doctor a great engineer in times to come. I thank you in advance for clearing JEE Main, for clearing JEE Advanced and NEET in flying colors. Thank you, thank you, thank you. With a deep breath in and a deep breath out, slowly and steadily, you may open your eyes. Slowly and steadily, you may open your eyes. All right, class. So we'll begin with the class for the day. Today, we'll be reading kinematics. From the previous chapter, there are two topics, that is screw gauge and significant figures, right? Although I had provided you all with a brief summary on the group, but still, I'll be discussing these topics in due while, don't worry, right? We'll come to these topics. These are two small topics, but I want you all to first go through the PDF which I've provided you all, which has a good understanding of how a screw gauge works, how a vernier caliper works. More like it has been explained diagrammatically, right? As well as you have been given the notes for significant figures. So I want you all to please go through them, right? Try solving the questions given there. In case you have any queries, you're always welcome to ask, but we'll also be covering those two topics in the classes in the meanwhile, right? Yes, so let's begin. Siddharth wants to ask something. Yes, Siddharth.
Sorry, sir, like phrased by mistake.
Okay, no worries, no worries. Right. So let's begin with the class. So I think there are some students still entering. I would once again give this clear directives to all of you. Once again, please listen this carefully. This is a class, although it's free of cost, but it is free of monetary cost, right? It is not free of discipline. It is not free of hard work. You still have to be disciplined. You still have to put in your hard work, right? Please listen carefully, everyone. I think there are some students who just entered. For all of them and for everybody in the class, that make sure that every day you are into the class by 8:50. You all will be asked to wait for 10 minutes in the waiting room. Stay there, right? Stay there. Put your mic on. That is call via device. I think the option is there on the right bottom, on the left bottom. So you can use that, right? And be in the class for 10 minutes. In that time, use that time and revise whatever we have read in the last classes, right? So this has to be your everyday work. I'll repeat, this class is not free, right? It might be free monetarily, but it is not free of discipline. It is not free of hard work. You still have to do hard work. You still have to come in time. You still have to be regular, right? So I am very clear, like I'm very sure that all of you are clear with what I've just told. Let us start. In case there is still anybody who has any query with regard to the discipline, regularity, please let me know, right? So let us start. All right. So for today's class, we are going to see the topic kinematics, right? Kindly give this heading in your notebooks. Right, let us start. So for this particular chapter, you have a range of questions and range of concepts that are inbuilt, right, in the chapter, in the general chapter, as well as exclusively. So before we begin class, there is something important with regard to the concepts that would be dealt in this class. This chapter makes use of certain very essential mathematical tools, right? And every year there are good number of questions which are covered from this chapter. So let us start off what kinematics includes, right? So if you see, according to your NCRT, this basically covers two chapters: one dimensional motion and two dimensional motion, right? But in order to understand this chapter clearly, you'll also have to have a very good understanding of the mathematical tools, right? And what kind of mathematical tools, like the chapter called vectors, right? Similarly, the chapter called differentiation, integration, right? Kindly jot this down in your copies quickly. Some concepts from trigonometry, especially trigonometrical identities, right? So we'll see that first quickly, then we'll transit to one dimensional motion, right? And finally to two dimensional motion. Kindly jot this down in your copies as we start, right? All right, class. So let us begin. Let us begin. So I hope that all of you are very well aware with some simple concepts, right? Some simple concepts, like also concepts like graph become very imperative, that you know how to calculate the equation of a line, etc., right? So we'll be seeing them all one by one, right? Please note it down in your copies, right? So once done, please raise your hand so that we can start off. Yes, class. As you have written it down, please raise your hand so that I'll know that you have it in your copies, the index for the day. Therefore, we begin. All right. So I can see there are hand raises. Okay. So let me see how many of you. I think there are 15 of, there are 18 of us, and Mugundan is yet to write. All right, Mugundan. Mugundan, if you are done, please raise your hand. Yes. All right. Thank you, everyone. You may bring your hands down. So now that you have noted down these topics, let us start, right? There are even some simpler topics. I hope you all know about it. Quadratic equations, right? The basic form of a quadratic equation is ax square plus bx plus c is equal to 0, right? We know that in such a scenario, the root is defined as value of x which satisfies this equation. Satisfies this equation. These are some basic mathematics equations and concepts which are imperative when it comes to understanding physics in long run, right? So across this span of your course duration, I want you all to be very clear with these concepts, and so I'm taking it up. Remember, yesterday we had discussed about learning of the dimensions, right? So today I might ask anybody at any point of time the dimensions, at least the first 5 dimensions which are given in the PDF given to you, right? The first 5. I can ask anybody to answer at any point of time, right? We can test the students today on the first 5 dimensions, right? And today you have to memorize the next 5, right? Make sure that you are memorizing for you. I believe that you all have already memorized the first 5. The first 5 right? And you will be memorizing the next 5 today itself, right? I can test anyone at any point of time during the class, right? Please make sure that you use the PDF and remember these dimensions, 5 dimensions a day, so that by the end of 1 week, you all are done with all the assignments and the chapter becomes clear for everyone, right? Short chapter, easy chapter, the first one which we have covered, right? So continuing, ax square plus bx plus c is the equation called as quadratic equation because the highest power of x is 2. The value of x which satisfies this equation is called as root. Okay, class, before we even proceed ahead, it is very important that whatever we have covered, you all have to make sure that you are doing a thorough revision every day, right? Thorough revision every day. Every day you're solving or at least trying to solve the assignment and attending the evening classes where we discuss this assignment, right? So you have to come to those classes. Even if you think you're underconfident, still come, still attend and ask your queries, right? So make sure that there'll be no missing out of classes, be it regular or the evening clarity classes. And every day you have to make sure that you are doing a revision of the concepts, right? Otherwise it will be something coming in, the rest behind going back. Make sure that does not happen. All right. So here sum of roots is given as x1 plus x2 equal to minus b by a, and product of roots, that is x1 into x2, is given as c by a. Write it down. Very simple, yet it should be remembered by all, right? Now we all know that root for any equation is given by the expression x is equal to minus b plus minus under root of b square minus 4ac upon 2a. B square minus 4ac upon 2a, right? Please write this down. This is the value of root of the equation, right? We'll have a lot of such expressions coming up in the first, like in the chapter which we are covering, the 1D motion and 2D motion, right? There'll be many equations for which this expression will be required. This is generally taught in class 8th, 9th, 10th. So please remember that such expressions do not have to be taken for granted, right? Okay, so let us move to the next page. Now, after you have understood what is quadratic equation and revised it, there are certain kind of sequences, right? Certain kind of sequences which are a great importance when it comes to physics. One of the sequence which is going to help you all will be geometric progression. Geometric progression is a progression where you have, if the first term is a, the next term will be a into r. Another term will be again a into ar into r. So every time, see what I'm doing. I'm multiplying by r the previous term to get the next term. I'll repeat. I'm multiplying the first term with r, second term again with r, and third term again with r. This is making a geometric progression. Here, what is a? A is just a number which is called as the first term. What is it called? First term, right? And r is called as common ratio. Common ratio. Now, example. Suppose you have first term as 1, right? And common ratio as 3. So how will your geometric progression look like? Something like this. A, that is 1. A into R, that is 1 into 3, right? And then again multiply 3. That is 9. Multiply 3. 27. Multiply 3. And so on, right? I hope the message and the content is clear to everyone, right? Suppose now you have a specific kind of geometric progression which is called as infinite GP. GP is geometric progression. Infinite GP. Now for an infinite GP, there is no end to the number of terms. Here, right, here the last term might be, let's say, suppose this is the second term, right? So this is a into r power 1. This is third term. This is second term, right? This is fourth term. In the fourth term, see, you have 3 here. In the third term, you have 2 here. In the second term, you have 1 here. So in the nth term, you will have n minus 1 here, right? So until now, we had, first I introduced to you a general geometric progression. Now see a specific kind of geometric progression which is given as A, AR, AR square, AR cube, and so on until infinity. So this is called an infinite GP. Now let us take an even subcategory which is called as a category where we take the value of r as less than 1. See here, common ratio was 3. That is, you were multiplying 3 every time, right? You were multiplying 3 every time. Now suppose I take the common ratio which is less than 1. So let's say the common ratio is 1 by 3 this time, right? So how will your progression look like? Suppose the first term is 1, right? Now the geometric progression will look like 1, right? 1 into 1 by 3. How much does it become? 1 by 3, right? Then multiply 3 again. It becomes 1 by 9, right? Multiply 3 again. 1 by 3 again. How much does it become? 27. And so on and so forth, right? So all I'm trying to say is just have a look at what I have written and try to absorb. Complete your work as soon as you're done writing all of this and as soon as you have understood, right? Please raise your hand. When you're done writing what is written on the board and you have understood the contents of the board, please raise your hand. Yes. Okay, keep your hand raised, right? I want to see once you are done. So I can see that there are some students who still remain to raise their hands. Okay, okay, all right. All right, I think all have raised hands now. Right, thank you class, you can bring your hands down. Now, this special type of geometric progression which I talked about, that is infinite geometric progression where r value is less than 1. For such a geometric progression, we write sum of its terms given as a upon 1 minus r. I'll repeat, a upon 1 minus r. This is the value of sum of the terms in the series. You also denote it by S infinity. S infinity means sum of all terms till infinite values, right? What I want to say, elucidating it with an example. So suppose you have a term, let's say, let us start with 2, right? Now you multiply, let us say this is first term, common ratio this time is 1 by 4, right? So how will you write your terms? 2 first term, right? Second term will be 2 into 1 by 4, right? Next term will be 2 into 1 by 4 whole square. Further, 2 into 1 by 4 whole cube, right? 2 into 1 by 4 whole power 4, and so on till infinity. Now, if I want to find out the sum of these values, right? So this is progression. Now, when I sum these values, see, have a look, and call this sum as S infinity, I can write S infinite is equal to first term upon 1 minus common ratio. First term is 2, right? 1 minus common ratio. Common ratio is this time 1 by 4. So we'll have 2 upon 3 by 4, which brings me 8 by 3 as the answer. So 8 by 3 is the sum of all these terms. All of them have sum as 8 by 3. Right? Yes, Siddharth, tell me.
So I keep leaving it raised by mistake. I'm so sorry.
That's okay. Okay, no worries. All right. So, everyone, please jot this down. Now, coming to another concept in coordinate geometry, right? That is graphs, etc. Give the heading coordinate geometry. Right? So in coordinate geometry, you have some concepts which are of super importance. One by one, we'll note them down, right? First thing, what is a graph? You all should know, right? Something a student who has cleared his school education or is in the last end of his school education should have a very good understanding of what graphs are, specifically when you talk about science students. And now it is not just about science, even the commerce students should know how graphs work, right? So you have a graph has two axes. Right now we'll take two axes. Let's say it's a 2D graph, that is a two-dimensional graph with one axis called as y, the other called as x, right? Now in order to locate any point, I will name it, let's say, P. In order to locate any point, I will have the location of the point in terms of the numberings or markings, calibrations on x-axis, and markings, calibrations or numberings on y-axis. Correct? Suppose this point, I call it as A comma B. What does this mean? Right? So this means that when I measure the distance of this point from the origin, along the x-axis. Remember what I'm saying. When I measure the position of this point from the origin but along x-axis, the position of this point is given as A, right? This position is called as A. Now, the position of this point along y-axis, from the origin is called as B, right? So I'll number and name this here. So this is the position of the point from or location with respect to origin, right? In terms of distance along x-axis and distance along y-axis, right? I hope I'm clear to everybody, right? So this is what is called locating a position on the or a point on the x-axis, right? Now in order to find this distance from the origin, we all know this distance from the origin, let us name it as r, right? Let us name it as r. So this r is given as under root of, right? Suppose the location of origin is 0 comma 0, right? So this r is given as a minus 0 whole square, right, plus b minus 0 whole square, right? Or you can simply write this down as r is equal to under root of a square plus b square. I'll put it here again. Now, talking about something called as straight line. Let's say you have, this is y-axis and this is x-axis, right? Any straight line on an xy graph, let's say the line is y and this is y-axis and this is x-axis, right? Now, any general equation of a line, general equation of a line, you all have read it in your 9-10 standards, right? Is given as y is equal to mx plus c, where what is m? Slope of the line. What is c? Is the y-intercept. Many students, right, still don't know what is intercept. So giving you an idea of the same in a quick gist, intercept is the amount of the distance between the point of intersection of the axis of the line with y-axis and origin, that is this distance. This is called as intercept. Which intercept? Because it is along y-axis, it is called as y-intercept, right? Even if you didn't knew it earlier, now you know it, right? So please note it down. This is called as y-intercept, or you call it c. Now, talking about m or slope, we know that what is slope in general, in life terms. What is slope? Slope is basically the steepness, how steep a line is, right? Suppose I have 3 lines here, right? I have 3 lines here and I'll try to measure what is the slope of these lines with regard to this orange color line, which is telling me the direction of horizontal. Orange line is telling me direction of horizontal, and I want to find out the slope of the 3 lines just told, that is brown, black and green color lines, right? So as I just told you all, that what is slope? Slope is steepness. We give this slope as m is equal to tan theta, right? Where what is theta? Theta is given as this angle between the line and the horizontal. So for each of the line, theta is different. For green line, theta is the minimum. For green line, theta is minimum. So suppose let us call this as theta 1. Second one, let us call this as theta 2, or let me take it as for another color. So let us say I am taking this with blue color. This is theta 1, this is theta 2, and the largest theta is theta 3, right? So we'll write theta 1 is less than theta 2 is less than theta 3. Theta is the angle, where angle between the line and the horizontal, right? Keep this in mind. Theta is angle between the line and horizontal, right? Now, once you know this, know one more thing. What? As theta increases, as theta increases, tan theta also increases, right? And therefore slope also increases. Please note this down. when theta increases, tan theta increases, and therefore slope also increases. So basically, I use this upward arrow to indicate an increase, right? Please jot this down in your copies. Now, let us take an example, right? Suppose you have, okay, we'll come up with the example after I'm done with the with more such expressions, right? So I hope you all are very clear with the understanding of this line y is equal to mx plus c, right? Giving you even a shorter equation which you can use to express such lines, right? So suppose I have this time, this is a shortcut, right? And is called as intercept form of equation. Suppose this is y, this is x. Now I have a line given as something like this, right? So where is it cutting x and y axis? Have a look. This is cutting, let's say, y at a point y is equal to b, and it is cutting x here axis at a point x is equal to plus a, right? So for such a line, this brown color line which I've just drawn, for this line the equation will be given as, it will be given as x upon a plus y upon b is equal to 1. So this is one of the shortest or the easiest way of finding the equation of a line. We'll see the usage of it in a very short while. Please jot this down with you. Somebody may ask that, sir, you are telling us about a specific case. How about if the line is no longer lying in the first quadrant? I hope you all are very well aware that in a graph, there are different quadrants, right? The quadrant where I have drawn the line is the first quadrant. This is the first quadrant. This is called the second quadrant. This is third quadrant, and this is fourth quadrant. Please note it with you. Please jot this down in your copies quickly. Right? Now let's take an example, right? Suppose in the chapter kinematics, you will have different equations. You will have different equations. Just a minute, class. All right. So I can just see a student just joined. So once again, a clear directive for all of you, right? You all are heading towards an aim, which is super important in deciding your careers and the life path from now onwards. So please make sure that you are not at all taking this class or this entire mission as for granted. Don't do that. That will have a very strong impact on your results, right? I am here to help you all for free. That does not mean that you are going to be slackened in the way you treat this course, right? Because this course may be free monetarily. This course is not free in terms of the hard work and discipline. So make sure that you are in time to the class at 8:50. Log in, right, and keep your classes ready. There might be some of you who might be waking up in the night studying. I really understand that this time is very precious for you, but so it is precious for other students also, right? So if they can do it, you too can do it, right? So please make sure that you come to the class early in time at 8:50, right? Don't take this class for granted, right? Okay, so starting once again where we were at the in kinematics, right? For the student who has just arrived in the class, we have read all of this. All this lecture will be available on YouTube for all of you. So please make sure, in case you have missed the class by coming late or by not attending a lecture, then you have to view these lectures before you come to the next class, right? So as I've informed on the group that the lectures will be every day. By before the end of the day, the lectures will be available. I'll try to make sure that they're available online, right? And the link has been given to you all. So this was the first page. Second, we read about geometric progression. Then we read about a specific kind of geometric progression, right? Then we read about the sum. How do you calculate the sum of an infinite GP? What is graph, right? Then we are seeing what are straight lines, all right? Then we are coming to the next part where in the chapter kinematics we are reading something more we'll require is the how do you decide about, suppose let's say, as I was saying, there are 4 quadrants, right? Suppose now you have a line given something like this in another quadrant. So let's say this is y-axis and this is x-axis, right? Now you're supposed to find out what is the equation of this line. How do you do it? Again, by the intercept form of the equation. Suppose this is given as x, y is equal to b, while this is given as x is equal to minus a. Why am I taking it as minus a? Because we know this side is for positive x-axis while this side is for negative x-axis. Upward is positive y-axis, downward is negative y-axis, right? So you will have the equation of this line given as x upon minus a plus y upon plus b is equal to 1, right? We all have to keep this thing in mind, correct? Please jot down this formula in your copies. Right. Now that you have, let me give you a short question, right, based on the same. So such questions are asked every year in your exam, almost every year, right, in your examinations. So question is, you have been given with a line, right? A line in this pattern. Have a look. Example. And this is one of the most probable questions. So please make sure that you are ready with it this year, right? This is a very probable question. I will give it 2 stars, right? A very probable kind of concept that you have to understand. So have a look. You are given with a line this way, right? You're given with a line this way. Uh, okay. I think Aditi, your mic is on. Do you want to ask anything, Aditi? All right.
No, sir.
All right. No worries. Right. So, class, let's see if you have this as y-axis, this is x-axis, right? And here we have been given that this point is 5 comma 0, whereas this point is 2 comma 0, right? You are being given that along the x-axis I am plotting time, whereas along y-axis I am plotting velocity v. Find the relation between velocity and time. Yes. So find it out quickly. How will you do it? You will have, okay, so let's take the answer. This one from Siddharth. Yes, Siddharth. How will you do it quickly? Let us know.
So the relation between velocity and time.
Yes.
So the slope of the graph is going to give us velocity and time, I think.
Just look at this equation which I have written at the top, or the equation which we just read in the past.
Oh, okay.
Here
So
we have
then
got.
every
So basically, what does the equation tells you? Any equation which is given in terms of x and y is telling you the relation between x and y, right? Right,
yes, sir.
Siddharth? So
So it'll. Acha.
yes, yes. So when you're told that along the y-axis you are plotting velocity and along the x-axis you are plotting time, and you are to
Time.
find out the relation, that means you have to find out the equation between v and t. Yes, go ahead, Siddharth. Try it
V and
out.
T. Yes, sir.
You'll be
So
able to do it. Try. Yeah.
so will it be x by 5?
See, instead of x, you'll write v or t. You'll write t by 5.
Sorry.
Yes, absolutely correct. Absolutely correct.
So
Yes.
that'll
Go
be
ahead.
t by 5
Yes.
plus v by
V by
2
2 is equal to
2. So that'll be 0, comma
is
2 by
equal
5
to 1.
on the y-axis.
Yeah, is equal to
Is
1.
equal to 1.
1. Absolutely correct. Absolutely correct, Siddharth. So this is how
Yes, sir.
we all are going to learn to plot the equation between v and t. Right now, suppose you want to express v as the subject. How will you write it? V by 2 is equal to 1 minus t by 5. Right? Then v is equal to, make it a subject, v is equal to 2 times of 1 minus t by 5, right, which gives me 2 minus 2 by 5t. Correct? So this is what this is giving you. This is giving you the equation between velocity v and time t, given as v is equal to 2 minus 2 by 5. Correct? So Siddharth, are you clear with the concept?
Yes, sir.
All right. So everybody, is everyone clear with the concept? If yes, we are going to give you a sum, right? Try it out and let me know in case you all have queries, right? So let us go to the next page, and here is the question for all of you. So yeah. So now you are given x and y axis. Let's take them this as y, vertical, horizontal axis is x, right? And then you are given this as x, this is y, right? Now you are being told that there is a line given this way, correct? This point is given to us as 10 comma 0. This one is given as minus, sorry, 0 comma minus 7, right? Along the x-axis you are plotting this time t, and along the y-axis you are plotting this time displacement, or let us name it as x. So for the convenience of everyone, I am removing the x and y written on the board. So let me remove this and this, but just keep this in mind, which is x and which is y-axis. Now find the relation between x and t. Right. So Abhinya, try answering this question. Yes, Abhinya. Yes, dear student, quickly. Yeah, try it out. Yes, yes, quickly. Abhinya, try it out. I'll try to put your mic on. Yeah, go ahead. Even if you're wrong, that's okay. Try it out. You will be able to do it. I know. Yeah, try it out. Meanwhile, everybody will write the equation in their copies, right? As Abhinya is trying.
Sir,
Yes, Abhinya, go ahead. Yes, x upon. Okay, Abhinya, tell me the formula that we have just read now. Yeah, I'll just bring the sheet there. Yes. So please read this formula. Yeah, this one. Yes, Abhinav. Go ahead. Yes,
X by
Abhinav.
A plus Y by B is equal to 1.
Yes, absolutely correct. Absolutely correct, Abhinav. So now use that formula here. X here, instead of X, you have T, right? So you'll write what? Instead of X, you'll
T
write
by
T by, yes,
T by 10
T by 10.
minus X by 7 is equal to 1.
Yes, plus X by minus 7 or minus X by 7 is equal to 1. Absolutely correct. Absolutely correct, Abhinya. Appreciate it. Thank you. Right. So now let us take the next one. I hope you all are now clear with this concept, with this example. I would like you all to take next one as this. You are being given now, you are being told next point of discussion is that try to find out yes, Harsh, tell me, you want to ask something? Yes, Harsh.
So I had a doubt. I cleared it myself. Thank
Okay,
you, sir.
okay, right. So yeah, so basically let's say if you have this now again as y-axis, this as x-axis, correct? Now you're given with a line. How do you identify if the slope is positive or negative? A line which is rising in nature has positive slope. See the line which I just drew, the blue color line. This line has positive slope. Why is it positive? Have a look. Because this theta, whenever, how do you give slope? Slope is given as tan theta, right? Now, remember this, that whenever theta is less than 90 and greater than 0, it's called as acute angle, right? So in that case, tan theta, or basically the slope, is always positive, right? And whenever theta is between 90 and 180 degrees, in that condition, tan theta or slope is negative. Oh, sorry. Yeah, negative. Correct. So please jot this down with you. How will you define slope is positive or negative? So let's say I draw another line. This time, this orange color line, right? So see, this line is falling. This is called a falling line, right? I'll write it here for everybody's convenience. This is called, the first one, blue, is called a rising line. This is called a rising line. And this one has slope as positive, right? Whereas, how about the orange line? This one is called a falling line, right? And why is it called a falling line? Why? Because see, along the x-axis, x is increasing, right? Whereas y is decreasing along the line. See, here this is the value of y, right? Then as we move ahead, value of y decreases, then more ahead, y even decreases, ahead y even decreases, right? So you're seeing that y is decreasing, y is decreasing with increase of x. And see how is this angle obtuse? See, this angle is called as obtuse angle, which this falling line is making. This angle, see, have a look, the one which I've just drawn, I will mark it with pink, this one, right? So this is the obtuse angle, whereas the one which I have drawn with green, I'll try to underline it with black, right? This one, this is the acute angle. So in an acute angle, whenever the angle is acute, the line, the angle between the line and the horizontal, if that angle is acute, as was the case here, the slope is positive. Whereas if the line is falling, right, or the angle is obtuse, you call the slope as negative, right? So I will write here m value. Here m value is negative. Please jot this down with you. Please jot this down quickly. Yes. As soon as you are done, you may raise your hand, right? Or let it be, let it be. All right, let it be. Need not raise hand. Thank you everyone. Let it be. No worries. Just jot it down. I'll wait for a minute in general for everyone. No worries. Try to absorb whatever we have read. No, just take a minute, try to absorb everything one by one, see everything in the previous notes which you have made and try to absorb everything. Just take a minute of silence, read your lectures again, right? In this is called in class revision. Revise in class itself, turn the pages of your copy and see what you have read. Yes, I'm giving you a minute for it. Yes, go ahead. Yes, Shivani, you have some doubt, let me know. Okay, all right. So now let us move to the next important part quickly. So you all have understood that how the slope is positive or negative, right? If the line is increasing, that if it is a rising line, then the slope is positive. It's a falling line, then the slope is negative, right? Don't go by the quadrant. Don't go by the quadrant. See how is the line oriented, right? Irrespective of the quadrant, when the line is making an acute angle, as was the case here, right? It's called a line with positive slope, right? And here, see, as the angle becomes obtuse, the line is called line with negative slope, right? So we'll go ahead with the discussion. Yeah. So now, how about the intercept, right? Intercept can also be positive and negative. Suppose this question will be answered by, so let us take today Krishna. Yes, Krishna. So suppose you have given as you have been given that I'll give you four different lines, or let's say, yeah, four lines with different colors, right? So let's say this one is green, then another line with a color blue, right? Let us take a line with color green, right? And let us say a line with color orange, right? Now, Krishna, you have to tell me that for these lines, how are the uh, like what is the value of slope and intercept, that is M and C, right? We all remember that equation of a line is given as y is equal to mx plus c, right? This is the general equation, and we have read one more form, x by a plus y by b, right, is equal to 1 if the intercepts cut by this line is y is equal to b, and here y is equal to x is equal to a on the x-axis and y-axis respectively. So you have to tell me, are the values of M and C positive or negative for each line, right? Suppose let us first start with a green line. Yes, Krishna. Here M is positive or
Sub
negative?
positive.
Positive. Absolutely correct. How about C? This value, is the Y positive here in the given scenario or negative?
So positive.
Positive. Absolutely correct. Why? Because I just told some time back that everything above x-axis is positive, everything below x-axis is negative. Absolutely correct. Right. Krishna, tell me the second one. So here, what about this blue line? Here, slope is?
Negative.
Why is it negative? Why is it
So
negative?
because obtuse angle.
Because the angle is obtuse. Absolutely correct. How about the intercept made by the blue axis?
Positive.
Positive. Absolutely correct. Yeah. Tell me about the third line. This one, the red line. Yes. How about the
So
slope?
negative.
Slope is negative. Sure.
Uh, yes, sir.
See, have a look. What is the angle which it is making with the x-axis? Is it obtuse or acute? The
No, sir.
angle is,
Accurate. It's positive.
the angle is acute, right?
Positive.
So the slope will be positive, right? So that is why I told you all
Yes.
that none of us have to get confused with the quadrant in which the line is placed, right? So whether the line is, I'll draw it here once again. See, have a look, everyone, right? So suppose I am drawing a line with a positive slope in all the axes. Everyone will have a look at this, okay? So suppose this is y, this is x axis, right? Now suppose I draw a line here. It's positive slope. I draw a line here, it's positive slope. I draw a line here, positive slope, draw a line here, positive slope. Why positive slope? Because don't get confused with where the line is placed. Doesn't matter. If it's making an angle which is acute with the x-axis, it is always having a positive slope, right? So whether it is here, slope is positive. Whether it is here in the second quadrant, slope is positive. Whether it is here in the third quadrant, slope is positive. Here also slope is positive. Whenever theta is acute, the line will have a positive slope. Whenever theta is obtuse, line will have a negative slope. This becomes very handy when you're solving the problems. It will come in a very short while. Yes. Krishna, tell me the next one. How about the intercept made by this red line along the y-axis? Is it negative y or is it positive y? So
So
intercept is
negative.
negative. Absolutely correct. Absolutely correct. Yes. So how about the next one here for the orange line? Tell me. The slope is,
So negative.
why is it negative?
So because it makes obtuse angle with the
Obtuse
x-axis.
angle with the x-axis. Absolutely correct. So slope is negative, right? How about the intercept? The intercept made by the orange axis, is it positive or negative?
Negative.
Negative. Absolutely correct. Thank you. Thank you very much, Krishna. Everyone, kindly note this down in your copies. I'll wait for 1 minute. Note this down in your copies. So class, I'll be writing some quick formulas here. Then we can have a short break before the next session begins, right? So here is the set of formulas. These are formulas with regards to trigonometrical identities that you have read, right? And some formulas with regards to differentiation integration. So I'm writing the formulas here, right? We'll also discuss these in detail, but first jot them down, right? So here are the formulas, some trigonometrical identities. The first one, we all very well know, whenever for the first time you have read trigonometry, for the basics, for those who know like who want to revise basics, telling them here, suppose you have a triangle. Let's say, what is trigonometry? First of all, trigonometry is the branch of mathematics which deals with triangles. As simple as that. I'll repeat, a branch of mathematics and science which deals with study of triangles and the angles and sides associated with a triangle, right? So now that we are talking about trigonometry, let us talk about a special triangle, a triangle which has one angle as 90. Such triangles are also called as right angled triangles or simply right triangles, right? So in such a right triangle, let us take one angle to be equal to theta. How much? Theta, right? Suppose this angle is A, B, and C, right? Now, what is the value of sine theta, cos theta, tan theta? These are three trigonometrical ratios that you all should know always. Sine theta is given as perpendicular upon hypotenuse, right? So for theta, this adjacent side is called as base. This longest side of the triangle is called as hypotenuse, and the side which is just opposite to theta is called as perpendicular, right? Perpendicular. Right? Let us me name this as P, this as H, whereas this as B. Now sine theta is perpendicular by hypotenuse, right? Cos theta is base by hypotenuse. Tan theta is equal to perpendicular by base. Please remember that perpendicular and base can change their positions. I will repeat. Perpendicular and base can change their positions. How? Have a look. It depends where do you keep theta. See. So suppose you have theta over here, right? The way we have drawn. So for this theta, the adjacent side will be called as base. The opposite side will be called as perpendicular. But what if you place theta over here? Now the adjacent side for theta becomes this, and therefore this will be base, whereas this will be perpendicular. This is a very quick trick, right, where many people fall short of it, of understanding this in several exams, although it is taught in your class 9th and 10th standard. But no worries, we'll do a quick revision, right, before proceeding ahead. So please jot down these quick tricks, right, and the identities as under, right? So there are some trigonometrical identities which link two theta to theta angles. See which ones. You have sine 2 theta given as 2 sine theta cos theta, cos 2 theta given as cos square theta minus sine square theta, and tan 2, in fact for cos 2 theta we can write other expressions also. Cos 2 theta is given as 2 cos square theta minus 1, right, or 1 minus 2 sine square theta, right? Then we have next ones are given as tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. So these are some simple trigonometrical identities you all must know. Very simple ones which you have already read in your junior classes are sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta, right? 1 plus cot square theta is equal to cosec square theta, right? Please jot this down. After this, has everybody jotted this down? Please raise your hand if yes. So once you finish writing, please raise your hand. I'm waiting, class, right? All right. All right. So I think there are two more students that remain, Mugundan and Rashad. So dear students, in case you're done, please raise your hand. So Mugundan, are you done? Please raise your hand once yes. Right. So coming to the next one. So thank you all. You can bring your hands down. So your next identities are differentiation and integration based identities. Writing them here. Or in fact, we can do one thing. There are some more identities related to sine and cos theta. You can jot them also. You have sine 90 minus theta given as cos theta, right? Cos 90 minus theta given as sine theta, right? Then you have sine 180. So when I'm writing 180, it implies degrees, right? 180 degree plus theta is equal to sine theta, right? Sine of 180 minus theta is given as again sine theta. Similarly, you have cos 180 plus theta is given as minus cos theta, right? Similarly, cos of 180 minus theta is equal to minus cos theta. You all need not memorize all of this. I'll tell you a trick how to remember this. I'll tell you a trick, right? You need not memorize all these values, correct? Now you have, these are some important values, right? Then we are seeing differentiation and integration formulas. We'll understand what is differentiation and integration in brief after the break, right? So please jot down these values: differentiation and integration, right? So for differentiation, you have some formulas given as. So please correct one formula. This will be okay. Yeah, this is correct. We are correct. Yeah. Or one more formula you can add them here. Cos 90 plus theta is equal to minus sine theta, right? And sine 90 plus theta is equal to, or wait, just a minute, just a minute. I'll write both then for you, plus also. So cos 90 plus theta and sine 90 plus theta will be equal to plus cos theta. Please jot down these formulas. Yes. So these are some formulas, right? Many students try to memorize it. You need not memorize all of this. Now I'll give you all a trick after the break, which will make all of this so easy that you'll feel that how easy it was. Why were you worrying for so long? No worries. So yeah, have a look. Differentiation formulas are given as d by dx of x power n is equal to n into x power n minus 1, right? d by dx of, right, d by dx of e power x is given as e power x, right? d by dx of log of x to the base e is given as 1 by x, right? d by dx of we have d by dx of sine nx, or let us say sine x first. Sine x is given as cos x d by dx of d by dx of cos x is given as minus sine x, right? d by dx of tan x is sec square x, right? Some common formulas, jot them down. Similarly, suppose you have now instead of x, if you have a plus b, right? Ax plus b. Suppose instead of here you have, there is something called as, we'll be reading about something called as chain rule in differentiation. What is chain rule? We'll have a glimpse into it. Chain rule says that we have, suppose d by dx of x square. By this formula, it is 2 into x ka power 2 minus 1, that is 2x, right? But suppose I ask you d by dx of z square. How do you like find answers to such equation? You write similarly 2 into z, just we wrote the way we wrote here 2x, but since this z is not x, so you write here dz by dx. I'll repeat. Suppose you have now next time d by dx of, right, ax plus b, right? let's say ax plus b square. Now, had this expression been x, you would have simply written this as 2x, right? So you will write 2 times of ax plus b, but then you will multiply this expression with d by dx of ax plus b. This is called as chain rule. You assume something as x, differentiate it, and you multiply with the entire expression the differentiation of the assumed value. See, I'll repeat, d by dx of ax plus b whole square, right? Now, had this been x, so what had you written? D by dx of x square would have been 2x. But since this is not x, so what will you do? You will just write similar expression first, 2 times of ax plus b, but this was not x, right? So you will write into d by dx of ax plus b. Whatever you assumed to be x, you multiply the expression with it, right? This is called as chain rule. We'll see more about it. Until then, have a look here. D by dx of a constant is always 0. Jot it down. This is the next formula. D by dx of a constant is always 0. And suppose you have d by dx of some constant, let's say k, into x or any other variable in x, what do? The constant always comes out. This is another rule of differentiation. I'll repeat, constant always comes out. So you will have this as k times of d by dx of x. K times of d by dx of x, right? Constant always comes out, right? So class, we'll go ahead with a short break and we'll catch up in 5 minutes, or let's say 7 minutes. Let us meet by 10:35. Let us meet again by 10:35. Please jot down these formulas. We'll quickly see what all of these are, right, before we begin with the next section, right? And we'll also discuss the trick to remember these trigonometric identities, right? All right, class, let us meet back again at 10:35. It's 10:28 now. Let us meet by 10:35. Thank you. Welcoming you all once again to the session where we are understanding about different concepts which are related to kinematics and continuing kinematics further, right? So here in this chapter, as we have read some of the formulas in this class, what did we see? We started off with kinematics has several parts, like understanding you should develop first before you understand kinematics of what are graphs, right? What is differentiation, what is integration, what are vectors, right? And only when you are thorough with these identities, you will be able to clearly understand how one-dimensional and two-dimensional kinematics are put forward. Now we saw what is a geometric progression, what is a GP, right? What is an infinite GP, and how do you give the sum of an infinite GP? always make it a habit that whenever you write formulas, you should always put that in a square or a rectangle in this pattern, right? Have a look, see. Then we saw something about coordinate geometry, right? We saw how what does a point mean on an x and y plane. Then we saw the equation of a line. All of you understood the how do you find out the relation between x and y? An easy method which is called intercept form of equation. This x by a plus y by b is equal to 1 is called as intercept form of equation, right? Then we saw some examples of intercept form. Suppose if it is some other, if the line is no longer here, the line was cutting in the first quadrant. See here, this one line is in first quadrant. But what if line is in some other quadrant? So I told you that whichever quadrant line is in, you'll accordingly substitute this values of a and b, whether positive or negative, right? We understood that concept, correct? Then we all have seen, just a minute. Yeah. So then we all have seen some examples, right? Then we understood what is positive slope and positive intercept, negative slope and negative intercept mean. Whenever a line makes angle which is acute with the x-axis, that line has a positive slope. Whenever line makes an obtuse angle, right, as was the case over here, see this line is making an obtuse angle. See, this angle is greater than 90. Greater than 90 angles are called as obtuse. Less than 90 are called as acute. So we understood how do you understand whether slope is positive or negative. Then we started with trigonometric identities. What is sine theta, cos theta, tan theta. So welcome back everyone. There have been some electricity issues at my end because of which the session had got closed in between. Yeah. So restarting the session, right? So this way we had basically learnt of different trigonometric identities, right? Now coming to the point of different trigonometric identities, we had given some differential equations and some integral formulas, right? Let us continue. Class, in case you can hear my voice clearly and in case you can see the board, please raise your hand. If you can see the board and if you can hear my voice clearly, please raise hand. Yes. Just a recheck to ensure that I am accessible, my voice and video is accessible for all. Yeah. All right. Mugundan and Samriddhi, please raise hand in case you can hear my voice clearly. Please make sure I don't have to tell it repeatedly to separate candidates, right? Is there any issue, Mugundan? Is there any issue, Samriddhi, at your end? Please let me know. You can WhatsApp me, no worries. Yeah. So let us go ahead with, thank you everyone. You can bring your hands down. Let us go ahead with understanding the concept of differentiation, right? And before we do, a short insight into the trigonometric identities and how to learn them, especially the 90 minus theta as and 180 minus theta, right? Trigonometric identities, right? So the trick is that you have to learn two simple formulas, right? First one, the first one is sine of 90 minus theta. Whenever you're doing any kind of conversion and this angle is 90, right? Then always you will bring a complementary angle over here. That is, this will always be cos theta, right? Is that clear? Now, will the sign be positive or negative, right? That is decided by that in which quadrant, which angle is positive and which angle is negative. So suppose these are four quadrants. Let us name them as quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4, right? Right? So in this system, you should always remember that whether you talk about sine, cos, tan, all are positive in first quadrant. In second quadrant, sine is positive, rest are negative. All right. Here in the third quadrant, tan is positive, rest are negative. So when I'm saying rest, I mean cos and sine, right? Now, similarly in the fourth quadrant, when cos is positive, rest are negative. What does this imply? This implies that suppose if I have a line, just have a look, okay? So let's say I'll draw a line here, or let me take it in another quadrant. I'll make here as the line. Yeah. So suppose this is a line. What do you mean by being in the first quadrant? What do you mean by being in the second quadrant, right? You can ask that, sir, why are you saying that theta is positive, theta or theta is in first quadrant, second quadrant? Because see, here, this theta is lying in the first quadrant. What if theta goes here? Have a look. Now what is the value of theta? Now you can write here. Suppose this angle, we know between x and y axis, the angle is 90 degree. How much? 90 degree. And suppose this is theta. So now basically your angle of which this line makes with the x axis is 90 plus theta. So when we are saying 90 plus theta, it means this angle is lying in the second quadrant. I'll repeat. Have a look. Suppose 90 is lying over here. We know this is 90, right? And this angle is theta, correct? So this entire angle which the line is making with x-axis is called as 90 plus theta, right? Now suppose this line is lying in the third quadrant. So this was second quadrant. Now suppose let us talk about third quadrant. So what does third quadrant mean? Very simple, right? Now on a obvious note, this entire is 180 degree and this is theta, right? So what can you call this green line? This green line is making an angle 180 plus theta, right? So whenever I'm talking about theta, we'll always assume it is some acute angle, right? And we are writing sine and cos in terms of that. I'll repeat now the entire expression, right? See, have a look. So we wrote sine of theta, right? Sine theta is simply theta of an angle which is lying in the first quadrant, right? Now if I write sine of 90 minus theta, again 90 minus theta. So you'll have, see this over here, right? So you have this entire is 90 degree, right? Minus theta means excluding this angle. So this will give you 90 minus theta. Basically 90 minus theta also means first quadrant. This is what I want to convey, right? And since this is 90, right? Since this is 90, so you'll convert it into cos, right? And how about sine? Sine is always in the first quadrant. How is sine in the first quadrant? See here, all are positive. So sine is obviously positive. So you put a positive sign. We'll take more examples. Now, in the initial go, something might be unclear, but slowly it will become clear, right? See, one more example. Suppose you write sine of, again, we'll take example of sine 90 now plus theta, right? Because it is 90, always whenever there is a 90-degree written, so you have to convert sine into cos and cos into sine, right? So instead of 9, because sine here 90 is there, so we'll write cos. Okay. Now, once we have written cos theta, how about sine? Acha, what does 90 plus theta will mean? See, this is 90 and this is theta, right? So 90 plus theta would basically means second quadrant, right? Your line is lying in the second quadrant. So when it's second quadrant, see here, everyone have a look. This is second quadrant, 90 plus theta. So what about second quadrant? See what is positive here? Sine is positive and the rest are negative. So see, sine is always positive. What are we talking about? Sine, right? And therefore sine should be positive. So here you will put a positive sign. This is a positive. This is the rule, right? For converting one angle into another. I'll give you one more example, right? Have a look here. Sine of 180 minus theta, right? Sine of 180 minus theta. So see, this is, you have been given as x and y axis. This is x, this is y. What does 180 minus theta mean? Have a look. This is the line, right? 180 minus theta. What is 180? 180 is this angle. This is 180, correct? Minus theta. That means this much you subtract. So this entire angle now becomes 180 minus theta, right? So 180 minus theta means line is lying in which quadrant? This was theta, right? This one was 180. So 180 minus theta implies second quadrant again, right? This time, instead of whenever we had 90, recall what we did here. When we had 90, we converted sine into cos. See here also, we had here in the RHS, see here also with sine we had 90. So we converted sine into cos, correct? Now, have a look. Here we have 180. So here we are no longer going to convert sine into cos. We will just allow it to be sine itself. So you'll write sine theta. Now, what about this minus sign? So we know that this is second quadrant, and have a look in the second quadrant. In the second quadrant, sine is always positive. Sine is always positive. So over here, what is the main angle we are talking about? Sine, and sine is always positive in first quadrant. So you'll put a positive sign here, right? Doing the same conversions, right? Doing the same conversions with cos theta, right? Suppose we have cos 90 minus theta, right? We have cos of 90 plus theta. We have cos of 180 minus theta, cos of 180 plus theta, right? These are degrees, okay? We'll see the conversions once again. So again, cos of 180 minus theta. So your step one, how do you convert? The trick has different steps, right? So the step one is identify the quadrant. Identify the quadrant. Okay, so I'll remind you all this whatever I'm teaching you all know, this will become very handy when we'll be doing the chapter SHM and waves, right? That is oscillation and waves, right? So in the chapter oscillation and waves, we will have the application of this sine and cos a lot, right? So that is why we are doing everything in advance, right? So there our workload will reduce by paramount levels. So have a look. You have cos of 90 minus theta. Have a look. So cos 90 minus theta, which is the quadrant that we are talking about? See, you have x and y axis. This is y, this is x, correct? 90 minus theta, that is 90, this is 90, right? Subtract some acute angle from it, right? That is subtract this much angle from it. How much are you remained with? 90 minus theta. So we are talking about first quadrant. So the first thing was to identify the quadrant, right? That is done. Now, second step, right? Second step is to see whether you have 90-degree written or 180-degree written, right? Whenever you have 90, then sine will become cos, right? Or cos will become sine, right? Suppose you have 180 written, then sine will remain sine, right? And cos will remain cos. This is the rule, right? And next rule, third part is you put the sign according to the rule all sine tan cos. See here, why have I written all sine tan cos? Because see, all are positive here. Sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. Now have a look. First step, step number 1. What is the first step? Identify the quadrant. We have identified it as first quadrant, right? Now, second, see if it is 180 or is it 90. Here we have this as 90. That means sine will become cos and cos will become sine. So here this was cos, so this will become sine. Correct? Now, write sine theta here. Now, to identify the sine, this is first quadrant, and in first quadrant, all are positive. So you'll write plus sign over here. You'll write a plus sign over here. Now, talk about the next one. This is done. See the next example. Cos of 90 plus theta, right? Cos of 90 plus theta. What is step 1? See the step 1. Everyone here, focus on the step 1. Identify the quadrant, right? Which quadrant will 90 plus theta be? See, this is 90. I'll draw here, right? To make the things clearer for every one of you. Suppose this is y-axis, this is x-axis. We are talking about 90 plus theta, right? Let's see which quadrant are we talking about. So here, this is the line, right? From the origin. Now, this angle is 90, correct? And this angle is theta. So this entire angle becomes, how much does it become? 90 plus theta. So 90 plus theta is second quadrant, correct? Correct. So we have identified the quadrant now. So here you have 90 plus theta is second quadrant. Now what do you see? Second one, is it 90 or 180? It is 90, correct? So sine will become cos and cos will become sine. What is here? Cos, right? So we'll write here instead of cos, sine theta, right? Now try to see the sine, right? So put the sign according to the rule all sine tan cos. So we are talking about the second quadrant. In second quadrant, what was the rule? Only sine is positive, cos is negative. And what is the chief angle here which we are trying to convert? Cos, and cos is negative in the second quadrant. See here, cos is negative in the second quadrant, and we are talking about cos, and therefore the sign here is going to be negative, right? Now once again have a look here. We have, this is done, right? Next one, we have cos of 180 minus theta, right? So again, identify the quadrant. Step 1. 180 minus theta, right? So what is 180? This entire is 180, correct? subtract some acute angle theta from it. Let's say we draw a line this way and subtract some angle theta from it, correct? Now this entire was 180, this was theta. So what is 180 minus theta? This angle is 180 minus theta, correct? That means 180 minus theta implies which quadrant? It implies second quadrant again, right? Now second step, have a look at the second step. Is it 180 or is it 180 or is it 90? It is 180 this time, right? So for 180, cos will remain cos and sine will remain sine. So here instead of cos you will write cos itself. Why? Because this was 180, correct? Now third one is looking at the sine. So have a look at the sine. Now in the second quadrant, which is the quadrant? The quadrant is second. Now let us look at the second quadrant. In second quadrant, only sine is positive, cos is always negative, right? So see here, this is, we are talking about in this question for cos. So cos is negative. So what is the sign that you're going to put? Negative, right? See, this is the angle or the sine or cos that we are going to consider, right? This one. Don't get confused with the answers. We'll see the question, right? In order to put the sign. Now, next one. First, cos 180 plus theta, right? So how do you do it? Cos 180 plus theta. First, identify the quadrant 180 plus theta. You draw the quadrants. This time, I would want one of you to answer. So let us take the answer from Pratham this time. Yes, Pratham. I'll unmute everyone, right? Pratham.
Yes, sir.
Yes, Pratham. So, so how do you do it, Pratham? Tell me first of all, which quadrant should it be? How will we identify? Let us draw a line. Okay, first, let us say this
Yes.
is y and x-axis, correct? Now, what does it read this angle? What is it written? 180.
180 plus theta.
So let us draw 180 first, right, Pratham?
Yes, sir.
So let us draw 180 over here, right? Now, this is 180. Add theta to it. So will you add theta
Yes.
by going in the second quadrant, or will you add theta by going in the first quadrant or going in the third quadrant? Where will you have to go? In the
So third quadrant.
third quadrant. Absolutely correct. Absolutely correct, Pratham. So let us take this as theta. Now, how much does this line make with x-axis? 180 plus.
Plus theta.
So which quadrant are we talking about? 180 plus theta is
Third.
which quadrant?
Third quadrant.
Absolutely correct, Pratham. Now, tell me if it is 180, the second step. We make cos as sine or we keep cos as cos only?
So keep cos as cos.
Cos only. Absolutely correct. So we'll write cos theta over here. Now, how about the sine? Now, in the third quadrant, have a look, Pratham, and tell me which one
Yes,
is
sir.
positive.
Tan.
Is cos positive here in the third quadrant?
No.
So cos
No.
is negative,
Negative.
right? So
Yes.
cos is negative. So this, what are we talking about in this question? Cos or tan?
Cos.
Cos. So which sign should come here in the third quadrant?
Negative.
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 Absolutely correct, Pratham. Absolutely correct. Are you clear with the concept,
Yes, sir.
Pratham?
Yes, sir.
Very clear?
Yes, yes.
Right, right. Also, thank you, Pratham, right? Thank you.
Yes, sir.
Also, one of the students, Fayad had told me that I had written one thing on the board, which was one sign. I had made mistake with one sign. So thank you, Fayad, for bringing that into attention. I am writing the same over here, right? We'll write, suppose now sine of 90 minus theta, right? Sine of 90 plus theta, right? Sine of 180 minus theta. Same way, the way we wrote it for cos, the same way we can write it for sine. Sine of 180 plus theta, right? You all kindly verify this at your homes, right? Do this as a homework, everyone. I'm putting it here. So you have sine 90 minus theta given as cos theta, right? Sine of 90 plus theta gives you again cos theta, right? Sine of 180 minus theta will give you sine in the second quadrant is positive. So positive. Then we are talking about 180. So sine remains sine. This is sine theta. Whereas sine of 180 plus theta, that is, this is giving the third quadrant. So for the third quadrant, you will have this as, okay, this is 180. So you'll have sine here, right? And then third quadrant, have a look. In the third quadrant, only tan is positive, sine is negative, right? So we're talking about sine here, so sine is negative, right? So thank you, Fayad, for bringing this to our attention. So the formulas which you all have written, right? Please make sure that these are the correct formulas which you have just derived. In case there are any errors, you can rectify them, right? These are the correct values which you have just derived here. Please jot these down in your copies, and once you are done jotting down this entire page, please raise your hand. Yes. Please jot them down in your copies and let me know as you are done by raising your hand. As you're done writing, please raise your hand so that I will know that you have written. Dear class, keep your hand raised. Please raise your hand as you're done writing. Shri and Manjunath. Manjunath, have you arrived late to the class? Okay, I'll talk to the student. No worries. All right. Thank you, everyone. You can bring your hands down, right? Uh, Please jot this second page also quickly with you. You can bring your hands down, class. Everyone, thank you. Please please write these formulas down with you. All right. So, class, now that we have done some basics of trigonometry, right? Some basics of quadratic equation, some basics of like a GP with infinite terms, right? I would want you all to remember these formulas, right? First thing would be to remember these formulas. I am giving in very gist some more formulas. Keep them in mind. See, I have also told you now the trick how to remember the formulas, right? Now you can create your formulas rather than remembering them. You can always recreate these formulas whenever need be. Also, please write this down here, that where you will be requiring them specifically. Although you require them anywhere and everywhere in physics, but specifically for your syllabus, you might have a great need when it comes to oscillation and waves, right? So that is the story. Here are some differentiation and integration formulas and a brief definition of what differentiation is. See, I'll write it here on a fresh page. So differentiation, right? Differentiation is, what is differentiation? Differentiation is basically defined as delta y by delta x, such that we take something called as limit of delta x being very small. We call this quantity as dy by dx or differential, right? This is called as first differential. Although you all have read this before, it is just a quick insight into what we have read before, right? This is called as first differential. Then there is something called as second differential, right? Which is nothing but second differential. This is basically d by dx of dy by dx. One more understanding to dy by dx is nothing but slope of the graph. Slope of the graph, right? Slope of the graph is called as dy by dx. It is also called as tan theta, which you had just read some time back, right? So there are different interpretations of differential. So when I'm writing second differential, you can either denote it by d2y by dx square, or you can also write it as d by dx of slope. What does this mean? What is the physical interpretation? See, I'll draw a curve here, or let's say a graph here. You have this as x-axis, this is y-axis, right? Now suppose you have some random curve here. Okay, now I'll draw a tangent to the curve at any given point. Suppose I draw a tangent like this, right? Now this line is a tangent, let's say at a point which I'm marking with blue color, right? So this is the tangent to the curve. Now at every point, observe that every point, if I make a tangent, the tangent will have a different slope. See why? Because theta will be different. What is theta? The angle which this line makes with horizontal or the x-axis, right? So at every point the slope will be different, right? So at every point the differential will be different, right? So you define differentiation as slope of the graph, or tan theta, or m, or as dy by dx, where what is theta? Remember, theta is the angle which the line is making with x-axis. Theta is angle made by line with x-axis, right? So further than this, let us continue the understanding of what integration is, and the relevant formulas I'll be sending you all on the in the PDF format on the group, right? I'll be sending the formulas for integration and differentiation, which are important for your uh, physics chapters in the coming kinematics. I'll be sending that to all of you via WhatsApp, right? Via WhatsApp. Let us today connect between in the evening from 7 to 8, right? And let us then continue with the discussion, right? So let us today evening connect between 7 to 8 and continue with the discussion. In that discussion, we'll be doing some of the numericals that we had left yesterday, right? We'll see what is integration and the formulas which we have read. I'll give you an assignment based on those formulas and the concept of differentiation, integration, coordinate geometry, etc. You will solve that assignment, right? And we'll meet up today between 7 to 8 p.m. right in the evening. So, and we'll then further continue this chapter kinematics in tomorrow's class. And if we can finish this chapter tomorrow, we'll be starting off with the uh, next chapter, right? All right, class. Also, right. So this is the very important note. Thank you, everyone. Thanks a lot. My end, right? Actually, here the electricity has gone away. So pardon me for the same. Pardon me for the same, right? We'll do one thing. We'll restart with our today's work in the evening class at 7 to 8. And please be in time. Thank you everyone for all the patience. Keep being your best. And I know you all do have a lot of things to do. With that, managing this would be a challenge for everyone, but still you are doing so much until this point of time. I'm really thankful. So class, thank you everyone. Keep have the positive spirit and know that our part is to give our best, and I'm sure you all are doing it. Okay class, let's meet at 7 p.m. in the evening. Thank you. Let us meet in the evening at 7. Thank you everyone. Thanks a lot. Thank you for all the patience and all the hard work you're putting in. Thank you everyone. Thank you. Thanks a lot. I know you all are doing
Thank you, sir.
it. Just keep doing it, right? Everything will happen in the right direction. Keep. Thank you all.
Okay, sir.